Hello and welcome to Crazy Danish Hacker. Today we're going to look at sniffing a voice call and frequency hopping. So first up, we are going to look at the channel in service mode, and that is 82. So that's ARFCN 82, and the frequency for that is 951.4 megahertz. So here it is, and now we will just convert that to hertz. That's very simple. There we go. And now we can use gr-gsm livemon, and we also need Wireshark. So here we have Wireshark, click OK, loopback, double click on that, move this, just copy the frequency and run this program. And yeah, that's fine up here. Gain 30, yeah, we can work with that. Copy and paste, click here, and it looks like it's working. So now that we've confirmed that we can capture data on this channel and the packages look nice, you know, they look like it's working, we'll just close this. Nope. And now we will minimize Wireshark and capture some real data, like from ourselves, obviously, because that's what we want to look at. So we are going to use GSM Capture, and then we will capture on this frequency. We can also specify just A and then 82, but we're going to use the frequency in this case. Sample rate is 1 million or 1E6. The max sample rate that you should use for an RTL-SDR is around 2 million, maybe 2.4, but not anything higher. So we can use gain 40, voice 1.c file. Time is 30 seconds, and hit enter. So now we can try and call ourselves. See if it's calling. Answer. Testing, testing. And we can see in service mode that frequency hopping is on as well, if you're looking at that. So yeah, so we'll just hang up again. And now we want to get the TIMC and KC, so we'll just get that now. So we will use the USB switcher, make sure that our phone is connected to the computer, because we need to talk to the USB modem. Now it's switched, and we can just confirm it here. Yep. We will use Minicom, the FTTY ECM0, question mark. Okay, it's working now. Control A set, E, and AT. And these should be the keys that we will need to decode some of the traffic at least. So we will just save it here. Don't need the 2 last bytes. And we will just hang up. So, yep. And now we can try and decode the data. So voice 1, yep, that looks like a nice file. It's 229 megabytes. We will run gr-gsm decode. Frequency is this one here. Sample rate is 1 million, 1E6. We will need to run, let's just see. C is voice, M is BCCH, time slot is 0, and open Wireshark and make sure that we're listening on loopback. And hit enter. And look for our TIMC. and string packet details. And here we can see that this is our phone, that it's not our phone, it's a message to our phone saying, hey, I want to talk to you. Let's chat on SDCCH time slot 1. Time slot 1. No hopping channels. And some good information, because we know that channel hopping was in use, is to look at system information type 1. We'll just sort it by this. See if we can find it, type 1. And basically this tower or BTS seems to work on these channels. So it's 82, 1110, 111, 12, just alright. So that's important to note for future reference. So we'll just close this, minimize, and now we will talk on, or not talk, decode SDCCH8 time slot 1. Make sure loopback is on here, that it's capturing from loopback, and we will just hit enter. And now we will search for our TMC again. So we will just make sure that it's there, find, and we will look for the ciphering mode command to begin with. So let's see, we got it here. Ciphering mode setting A53, yeah, that looks like what my phone wants to talk. Doesn't want to talk A51, at least not at the moment. So basically the BTS, or the cell tower, including the control, the computers and stuff, is telling my phone to let's communicate, but only with A53, like that it needs to be encrypted. So let's just close this, and since we have the KC right here, we can look at some of the more stuff. So we need to specify E3, that's A53. Key is this here. Make sure that we're listening on loopback. And now let's search for our TMC again. Let's try again. Nope. Well, I know that it's there because we have a CC setup right here. That's basically a package telling us that we are about to get a call, and that's basically the package that's telling who's calling. And then we have the assignment command, and that's telling us like where to call, for example. So we got here, the channels used for channel hopping again, and I think it is channel description. Yep. Here we can see that it wants to talk on time slot 7, so it's TCHF. So that's the traffic channel, and it's time slot 7, and it's training sequence 4, and it's hopping channel. Yes, MIO is 0, HSN is 60. So from here on, if we were not hopping channel, if it was hopping channel is equal to no, then we could try and decode the voice call as follows. So what we would do is that we would say M TCHF T7 E3 key, and then type in the key, and then D's full rate most likely, speech file, temp test1.eu.gsm. Now the problem is that because we're hopping channel, we're not going to get all or maybe any of the packets, even though we have the decryption key. But the thing is, we've only captured data from this frequency. So that means that we're not getting all of the data. So that's a major issue. So we can see that it is 0 bytes, so that's a major issue. So when I encountered this issue, I was looking at some stuff. I was looking into it if there were any solutions, and yes, there are. But you also need to understand the limitations that we have with an RTL-SDR. So an RTL-SDR can typically look at 2.4 megahertz at a time, maximum 3.2 megahertz, but that's with probable packet loss. So that's really, really bad. So let's see if it would be even possible in our case. So we go back to this website here, and we look at this. This is 91, yes, because this channel is most likely used. And let's see, 110. It may also be specified. No, it's not. So it may also be specified here. So that's 957 and 117. Just minimize this window. And now, as we can see here, like, it could be that our voice is only transmitted on these channels here, because that would only bring us a gap of 957 to 958.4. So that's equal to 1.4 megahertz, which we could pick up, even if we just allow room for like 0.2 megahertz or 200,000 kilohertz. So we could look at that, but like, even if it was like that, if it was something like 1.6, but the thing is, if our voice is just transmitted just one, like every few milliseconds on this channel, then we won't be able to decode it. And the problem is that if it is included here, then the range is 958.4 megahertz, and that's equal to 7 megahertz. So even if we had a lot of space, you can see we only have one RTL-SDR, and even if we're maxing it out, we won't be able to listen, because even if we are listening on this is both ways. So that means that if we're listening on, for example, 950, and let's say we are listening with 3.0 megahertz, then if we're listening on this channel here, then we have to then for wideband capture file, we are listening on 1.4 megahertz on both sides. That's plus minus. So that means that it is, the top channel is 951.5 and the lower one is 948.5, right? 950, yeah. So as you can see, in this case, we need something like a blade RF or a USRP, or we could do with less, but basically I need to buy a better software-defined radio to capture myself talking on the phone, if channel hopping is on, of course. So that's a major issue, even though there are programs to decode both the SD-CCH hopping and even the TCF-TCHF hopping as well. So that's what I'm going to try and do in the future. But for now, I won't be able to decode my own voice call. But I have a test file that we can try and decode instead. So let's try and decode a sample test file instead that I have. So this is from some of the researchers that originally published some issues with A51, or they released a tool called Kraken. So we will decode this file, and I will show you how it works, because this file is recorded and it doesn't have channel hopping on, so that means that we can decode it. We have the sample rate here, and we have the channel and key, so that's all we need really. So what we are going to do is that we are going to get this file first. So we will just GSM the test file, and wget. Shouldn't take too long, hopefully. So now that we have the test file, as in this is the test file right here, vfcall, we'll just rename it to test file or whatever. Test file, that's test.c file. We will use this file and decode it as we normally could with a voice file. But this is not channel hopping, so it is much easier. And in case I was not channel hopping on my phone, which doesn't seem to be possible to disable, then we could have done it on my phone, but I'll have to get a new SDR, as I said. Anyway, let's decode this file and do some magic. So we will see gr-gsm decode, and in this case it is this channel here. Sample rate is this here. A bit odd, I know. And mbcch time slot 0. Make sure we're listening, capturing on loopback, yes. And we also need the C file, obviously. We go. And we don't have the TIMC, but that should be fine. We don't really need it. Let's see. Paging. Notification. I wonder if it's the notification instead, that it's not the notification, that it's not the immediate assignment in this case. Let's just have a look at one of these notifications. No, I don't think so. Let's see, notification. I have a bad idea, because this is taking way too long. Just there we go. It's packet 287 or 286. So we'll just look at the channel description. SDCCH time slot 1. Let's have a look at this one. Time slot 1, hopping channel is off. Okay, good. Close, loopback, and C test SDCCH H1 time slot 1. Okay, there we go. So we got a paging response. That's what we are expecting. You can see that there's some information here. There is the TIMC right here, and the shifting mode command is A51. So now we just need to decode it again. So we'll just close and listen on the loopback again. And this time we will say it's still time slot 1, but we need to specify A51 and the key as follows, and decode it. And here we can see that it says CC setup. That's call setup, I think. So we can see here's the calling party number right here, and here is the assignment command. And if we look here, we can see that it's TCHF and it's time slot 5 and hopping channel is no. So that's very convenient, because that means that we can decode this file. So now we just need to remember that it's time slot 5 and it's TCHF. So what we are going to do is that we are going to just go back here, time slot 5, TCHF. We just need to make sure that it's capital letters, I believe. And just help, because I can't remember the arguments. Speech is probably full rate. Output file, temp, test file, speech.eu.gsm. Run it. And we can see some stuff here going on as well. But let's have a look at that file here. Test speech, test file speech, 8.8 kilobytes. And let's just move that file here. We may have to play it on a Windows machine, but we will just see. So I'm back in Windows to have a look at this file with VLC, because for some reason it's not working in Kali. So let's have a look. Let's see if we can hear it.
This is the test call 6.
I'm not sure if you heard that, so I'll just turn up the volume, turn it up max, you know.
This is the test call 6.
So that you probably heard. So just turn it down again so I don't blow my own ears out. So that's how you can decode non-channel hopping files. But when it's channel hopping, then we need some additional hardware, such as a blade RF, maybe a hack RF, or a USRP. Other software-defined radios can do, but if you want to do some serious SDRs that are not like crazy expensive, but they're also not too bad, but they're pretty good, then you need one of these, for example. So that's pretty much it. Stay tuned and subscribe.